Okay, so this little video is about calculating resistors in series and in parallel circuits. So the first thing is, if we have them in series, just remember series means they're in the same loop. So I would have my three resistors like R1 and R2 and R3 all in the same loop together. So with this, we want to see what happens to the total resistance of our circuit, okay? And when we add them together in series, we actually increase the resistance of the circuit. And to work out the total resistance that affects the current of it, we would just simply add the resistors together. So let's say this one was 2 ohms, this was 3 ohms, and this was 10 ohms, okay? The total resistance in this case is just going to be 2 plus 3 plus 10 to give me a total resistance of 15 ohms. So we can see that adding resistors in series increases the resistance of the circuit. When we come to do this in parallel, it's a little bit different, okay? So in parallel, it doesn't increase the resistance of the circuit, we actually decrease the resistance of the circuit. Just as a little recap, remember parallel means that we have alternative pathways, we have different loops. So at this point we could go up here, we could go across, or we could go down. So the resistors are in parallel to each other. Okay, so again, we've got R1, R2, and R3, and again I'm just going to say that this one's 2 ohms, this one was 3 ohms, and this one was 10 ohms. If I want to do the total resistance of the circuit, I've got to do the reciprocals of them. So in this case, 1 over R total is equal to 1 over 2 plus 1 over 3 plus 1 over 10. Now if I just quickly add those together on my calculator, if I do 1 over 10, oops, sorry, I just realised you probably can't see that, plus 1 over 2, plus, again, 1 over 3, that gives me an answer of 14 over 15, okay, so that's 1 over R total is equal to 14 over 15. Okay, so again, just if you can't quite see that there, I've just added those up. Now, just being really careful, this isn't the resistance, okay? This is 1 over the resistance. So to do our total, I'm going to have to flip this the other way around, so do 15 divided by 14. Okay, so in this case, if I do 15 divided by 14, that gives me 1.0714. We don't like to leave our answers as long decimals, so I'm just going to round that up to say 1.1 ohms. Okay, so in a parallel circuit, I have to add the reciprocals, but I have to remember as well that this is 1 over the R total, so I have to flip it, I have to turn it around, okay, to get my final answer. So you can see here, this has lowered the resistance of the circuit, so resistors in parallel lower the resistance of the circuit, and resistors in series increase the resistance of the circuit. Okay, so that's just a little quick recap of how we do the calculations of resistors in series and parallel.